Today, we'll learn how to create a speaker scene video for a podcast with Remotion and AI. As an example, we will take an episode of the Mostly Technical podcast by Aaron Francis and Jan Nensman. In this episode, they receive Adam Watton, the creator of Tailwind CSS, and they discuss about life and Tailwind stuff. The speaker scene will be a macOS-like application on top of a macOS desktop picture. There will be in the application a card per speaker with their name and their profile picture. The profile picture will be highlighted when the speaker talks.
Or whatever the hell it is. And then
you think you should do that before Christmas? I feel like you should really wait till after.
The first thing we can do is create a new Remotion project with create video -- Tailwind. We will use Tailwind because this is the kind of developer I am. We give a name to the video. And after a few seconds, the project has been created. We can open the project in VS Code and start the development server with npm start. We can now open the Remotion Studio in localhost 3000. The Remotion Studio is like a traditional video editing software. We can find the composition there, rendered as a video, the timeline, some controls to create a new composition, and many other things and many options. Let's give a look at the files created by Remotion. In the source directory, there is the index file. It setups Remotion. In the root directory, we can find the composition. Remotion uses React and web technologies to create videos, so you should feel at home if you are a React developer. In the root file, we import Remotion, set up the composition. We give it an ID and a link to the composition component that defines the composition we saw with the Tailwind logo, the title, and the subtitle. The logo, for instance, is defined in the logo component. It uses two SVGs to represent the waves of the Tailwind logo, and it uses the spring and interpolate function to create animations. This is how you create animations with Remotion. There is also the title and the subtitle. They both use the interpolate function to animate things. In the style.css file, Tailwind CSS is configured. You could add more classes there and configure Tailwind CSS as you do in another project. I choose an extract of 2 minutes of the Mostly Technical episode with Adam Watton. Before we start coding, we need to use an AI to identify the speakers. This process is called speaker diarization. To detect the speakers, I will use an open source model on Replicate. I upload the file of the podcast. I select the number of speakers. There are 3 speakers. And then I can start diarizing the file. After a few minutes, the segments have been created by the AI, and we can get the result as a JSON file. You can see that for each segment there is the start and the stop time and the speaker associated. The segments may overlap. We can copy the JSON file and paste it in the project. Now let's code the UI of the speaker scene. We go to the composition and we will clean things a little bit. We don't need them. We can delete. Absolute fill is a component coming from Remotion. It's like a div absolutely positioned with a full height and a full width. We can use it as the base of the code. The first step will be to add the background image. When we want to apply an image with Remotion, we need to use the EMG component. Remotion will wait for the image to load before processing the rest of the video. I copied in the public directory this background.jpg image, and we will use it. So src equals static file. With Remotion, to get an access to a public file, you need to use this static file function. Background.jpg. We give it full height, full width, and we want the image to be centered. So object cover, we want the image to cover all the available space, but we want to center it with object center. If we go to the browser, I need to relaunch Remotion, and now we see the background image. Now that we added the background, we can create the window. We go back to the composition, and instead of directly returning this absolute field, we return a fragment. With fragments, a React component can return several components. We create another absolute field component, and this component is made to be stacked. So if you add more absolute field components, they will be stacked on top of the others. Here, we create a div with a background, some margin, and it will take a full height. Okay, we had the base of the window. Now we can round it MD. It looks great, and we can add some shadow to Excel. Yeah, it looks great. Now that we have the window, we can add the grid with the speakers. So the first thing is to create a speakers array with the name, Adam, and we'll fill a color. I let it empty for now. And we have 3 speakers with Ian and then Aaron. I will pick the colors from somewhere because I don't remember them. Great. And now we need the pictures. I copied in the public directory the Aaron, Adam, and Ian pictures, and we can use them there. So picture equals static file. We will use that. GPG. And we need to remove this uppercase character, Ian, Aaron. Great. Now we can loop over the speakers. Here we create a new div with a grid, 3 columns, 1 row. We'll add some padding to the grid itself, and we need some gap. Create speakers map, speaker index. And we render a div. For now, we will just put the speaker name. Speaker.name. And we apply the key index. Okay, so yes, it's not really visible, but there is Adam, Ian, and then Aaron. We can continue to style this, so we don't put the speaker name there. We'll use background color, speaker.color. We should take the full. We'll continue. div. We apply the speaker name there. Speaker name. Okay. And we need the grid to take all the available width with H full, otherwise it won't. So yes, we have the color with the name. We can now, we will make it a grid to have two elements. The first one will be a div with the picture centered, and then there will be at the end of the components the name of the speaker. So grid roles, one FR and O2. So here we have another div. We duplicate it. Here is the speaker name, and there we will set the image of the speaker. src speaker picture. We can style it size 32 and mx and rounded full. It's important. We want it to be rounded full. Great. But that's not what I don't want just the image to be centered horizontally. I want it to be centered vertically too. So I will just use M02. No. Okay. Make it flex, justify center, item center. Remove this. Yeah, that's great. The image is centered, but we can add some box shadow to make it more interesting. So shadow XL. Yeah, that's better. Now we can style the name of the speaker. So we go there. We can add some padding. X2, a little of vertical padding. Yes. And we can add some text white and a background. We say, I think with some transparency. Yeah, that's not so bad. We can round this card now to make it better. The card is very rounded MD. Yeah, great. The next step is to highlight the pictures. For every speaker currently talking, we need to apply a green ring around the picture. Remotion creates a certain amount of images per second. It's based on the FPS parameter. We need to know when speaker talks, so what we will do is create an array with one item per frame for the whole video. In this array, each item will be an array, and this array will contain the name of the speakers that are currently talking. So it will be a nested array with each item being an array with A, B, or C, the identifiers of the speakers generated by the AI. We go back to the composition, and the first thing we should do is to update the schema. We create a frames property, which will be an array of strings. We use Z to define the schema. We can delete this. We go to the root component and need to update the default props. So default props will be frames to be an empty array. A video can be dynamic and based on external information. In our case, the video duration is based on the duration of the podcast extract, and the segments are generated by an AI. There is nothing static here, but Remotion is still able to generate the video. Remotion has some mechanism to generate dynamic videos. For instance, The GitHub Unwrap campaigns are made with Remotions. Every GitHub user gets a video of the contributions of the year on GitHub. We want to make things a bit dynamic, but not that much, so I think Remotion should be good. Remotion has a calculate metadata function. It's a property of the composition component, and it can return things like the duration in frames of the video or the props defined by the dot schema, like the frames. We will use this calculate metadata function to determine the duration of the video and which frames to render the video with. We go back to the root component and we set the calculate metadata prop to be an async function. As a reminder, the segmentation file is in the public directory and we will use it to extract the speakers. So the stop, start, and speaker labels, we want to get them, and then it will be used to create this frames array of strings. In the composition, we use a fetch call to get the file. We use a static file function to get a path to the file, segmentation.json. And then we can get the segmentation there with res.json. We can log this and see what's the value. Okay. And in the browser, in the console, there is this object. Yes, with the output. This is what we want, output segments. So we will use Z to parse this. So Z, we import Z, object, output, Z object, segments, and this is an array of objects with start, set string, stop, set string, and speaker, set string 2. Then we parse, we parse await res.json. And yes, we should be good. We can log it again. We can log console. Segmentation data, output segments. Yes, this is the array. The next step is to get the duration of the podcast extract. We can use a function called getAudioData from the Remotion media utils package. So we get AudioData, and the podcast extract is in the public directory in the podcast.m4a file. To get the data of this file, we do await getAudioData. Again, we need to use the static file function to get a path to the file, podcast m4a, and then we can log this. In the browser, we should see this audio data object with duration in seconds and many other things. We need to transform the duration in seconds into duration in frames, because there may be more frames than seconds in a video, and this is what Remotion expects. The calculate metadata function should return the duration in frames. But in audio data, we have the duration in seconds, so we need to do the transformation. I wrote a little function that does some math to create this frames number, so we will use it, and we'll say duration in frames equals seconds to frames audio data duration in seconds. Great. And we need to pass the FPS argument, because this is the base of the calculation. We will create a constant FPS equals 30, and then we can use it several times. FPS Great. Now we need to create this frames array with each item being a frame. So I create frames, and this will be an array of dynamic length. I use array.from for this, with the length being duration in frames, and I will fill each item with an empty array, which is an array of strings. Now we need to loop over the segments and fill the frames array. So for const segment of segmentation data output segments, and we need to get the start frame and the stop frame. The issue is that the start and the stop properties in the segmentation are in this string format with hours, minutes, seconds, and milliseconds. We need to transform it into a frame index. We go back to the root component and we will use this time2frame function that returns a number of frames based on this hours, minutes, seconds, milliseconds format. So here, time2frame segments starts. We need to provide the FPS too, and then time2frame segments stop FPS. Now we need to loop from the start index to the stop index and fill the frames array. We use a for loop for this with frame index and its default value being start frame until frame index reaches top frame. We increment the frame index by 1 and we take the frames at the frame index and we push the segment speaker. Now it should work. If we go to the browser, we see this error telling that we try to push to undefined. The issue is that the AI might generate a stop time that is outside of the bounds of the audio. So we need to add a guard to don't extend the frames array because we allocated a fixed length and we don't want to extend it. We go back to the root and there we add a condition. While the frame index is below the stop frame and the frame index is below the duration in frames, we loop. Now we can see the video, it worked. We need to do one more thing. We need to set the props and we need to define these frames props so the composition will get it and we will be able to highlight the pictures. Now that we created the frames array, we can get it from the props in the composition component. We will log it to see what's inside. In the browser we can find this, and this is a big array with 4,000 items, and you can see that for the frame 3, for instance, there is a A speaker, and if we scroll a bit more, for the 700 frame there is B and C who are talking at the same time. So now that we have this data, we can highlight the pictures. We go back to the composition and we will attribute the speaker label to every speaker because the AI gave A, B, and C labels to the speakers, but we need to match them in the speakers array. So speaker label will be A for Adam, B for Jan, and C for Aaron. We go to the image, the picture, and we will make it dynamic classes. This is static, and if, yes, we need to get another information. We need to get the current frame. To do this, we get frame with current frame hook in Remotion. We have the frames, we have the current frame, and now we can do if frames.frame includes speaker label, then we apply a green ring Green. For yes. Otherwise, we apply nothing. If we go back to the browser, we can hide this. We reload. And yes, you can see that the speakers are highlighted. If you move, different speakers are highlighted. There is one more thing to do to complete this video. It's to add the real audio of the podcast. So as a reminder, the podcast is in the public directory. What we can do to render the audio is to use the audio component of Remotion. We give it a source, again, static file, podcast M4A, and if we go to the browser, you should hear to the sound of the podcast.
Yeah, so we're saving up all these releases.
It's perfect. We did it.
Like Catalyst.
The video is now finished. The next step is to generate a real MP4 file, a video file, from this composition. Until now, we were previewing the video in the browser. Remotion wasn't rendering the video for real, it was displaying the React component in the browser. We can render the video with Remotion Studio or with the CLI. Remotion can also render videos with a Node.js package or in a Lambda function. To render the video in the Remotion Studio, we can click on the Render button. Then, we can select a bunch of settings like the codec to use, the frame range, and a lot more, but we will keep the default value. So we click on the Render Video button. After a few minutes, the video has been generated and we can find it on the Finder.
Yeah, so we're saving up all these releases for the...
Not
we'll have
too big a deal.
A couple days.
Use cases and
Mm-hmm.
I think Callus is like perfect for that. Like
Remotion is so exceptional. It's so great to be able to create videos with code. I really feel like the Superman of video creation thanks to Remotion. Thanks for watching this video, and I hope you want to test Remotion now. This video wasn't generated by Remotion or AI. I am a real guy. At least I think. But my French accent gives me away. Bye.